Hello everyone and welcome to our 5.1 through 5.3 quiz review. We're going to get started with a little bit of vocabulary at the top. The sum of the interior angles of a triangle is how many degrees? We did an entire discovery activity on this. Y'all worked really hard and figured out that no matter what kind of triangle it is, the interior angle sum is always 180 degrees. Remember when we ripped off the three corners of those triangles and we put them all three together, those made a straight line. So it's all three of those adds up to 180 and makes that straight edge. Okay, so 180, that's going to be really, really important for the rest of this assignment. If a triangle contains three angles that are all less than 90 degrees, then we classify it as an acute triangle. All three are going to be acute, and notice that says all of them are less than 90. If a triangle contains an angle that measures more than 90, so it's just you can only have one obtuse angle in a triangle, it's going to be considered an obtuse triangle. So it's obtuse if it has one obtuse angle, and that means that it's going to have two acute angles because that's all that's going to be left for the other two angles. If a triangle contains a single 90-degree angle, then it's going to be considered a right triangle. Again, those other two angles are going to be acute, but because it contains a right angle, it is a right triangle. So the only kind of triangle that is acute has to be all three angles being less than 90. If all three sides are different, then we classify it as a scalene triangle. So if we were doing that and you didn't want to use numbers, you could mark this as different than this. These congruence marks show that these are actually not congruent. All three are different values, and so that's scalene. If two sides are congruent, so if three sides are congruent, and then if two sides are congruent, we classify it as an isosceles triangle. That's where at least two of the sides are congruent. So we have those lengths being the same. The third length either being the same again or different, so isosceles. And then if all three sides of a triangle are congruent, then we classify it as an equilateral triangle. All of the sides are the same. And that was also where all of the angles were the same. All of the angles measured 60 degrees each. So each of those angles was 60 degrees. All right, so let's go ahead and start by classifying triangles 1 through 4 by its sides and then by its angles. Now, y'all, you have to be very, very careful when you do this because when it says by its sides, you need to make sure you're looking at the numbers that are on the sides and not the angle values. So the first thing I'll do is I'll make myself highlight all three sides. And so I'm going to do that for each of these shapes. The 13.8, those are the sides. 5.8, 4.2. So we're going to look at the sides only, not the angles first. So 2.8, 2.8, and 3.9. What does that mean for the sides? And so for the sides, that is going to be, because 2.8 is congruent in length, equal in length to 2.8, then I'm going to call that an isosceles triangle. What is it by its angles? Well, by its angle measures, I'm going to go highlight all three of those. It has two 45-degree angles, and then it has one 90-degree angle. And so we know that what that means is that this must be a right triangle. This is an isosceles right triangle that we will actually spend some time learning about those later on. Those are called 45, 45, 90 triangles. Notice the 2.8 matches on both legs and those 45-degree angles match as well. All right, let's go on to sides for the next problem. 13.8, 13.8, and then 13.8 units. So for sides, that means that this is going to be equilateral. What is it going to be for its angles? Well, let's investigate. All of those are 60. So a lot of you are going to want to say acute. While those are technically acute, that's not the most specific name. The most specific name for this is going to be equiangular. So you would need to put equiangular and acute if you're going to mention acute. The most specific name is equiangular. All right, let's go to the next one. The next one for side lengths, we have 5.8, 4.2, and 2.4. All three of those are different, and so that is going to be a scalene triangle. I always kind of think they're all scaled a little bit different. And then what about its angles? 121, 38, and 21. I'm not going to call that acute. Acute would be if all three were less than 90. It is going to be an obtuse triangle because it contains an obtuse angle. So 121 is what makes this obtuse. Just like the 90 is what made the other one right. It has to have one of those. You can't have more than one because of the triangle angle sum theorem being 180 degrees. All right, and then last but not least, we've got this last one, so 60, 40, and 80. I wanted to start with that because all of the angles are different. That's acute. But because all of the angles are different, I also know that all of the side lengths are going to be different. I know that immediately. So 7, 10, and 11, that forces this to be an acute scalene triangle. So by angles, it's acute. By sides, it is scalene. All right, and then we got into congruence. And remember that our congruence statement told us everything we needed to know, even if we didn't have a picture. So it says complete the following statement using the congruence statement. Y'all, they even tell you to use this thing. This thing is going to be a lifesaver, specifically when we start rotating shapes, reflecting shapes. This tells you everything you need to know. So while I have a picture, I am going to mostly rely on that congruence statement because it tells you everything that's in the same spot. So like W and G, those angles are going to be congruent. So let me go ahead and mark that. W and G are going to be congruent. Let's go V, angle V and angle H are going to be congruent, V and H. And then last but not least, we've got, for the other angle, we've got U is listed third, I is listed third. So U, 1, 2, 3, and then I, 1, 2, 3. Okay, so not only do we know that, but we also know the side lengths that are going to be the same. So y'all, let's go ahead and just mark this triangle up. WV is going to be congruent to GH. So here's WV, here's GH. You can see that this thing has been reflected and turned around. And so VU, this one right here, is going to be the same as second, third, HI, which means that WU, this third one, is going to be congruent to GI, this third one. And so you can kind of see it looks like a little smiley face shape with the eyes, and then the outside pieces make the mouth. But that's how you can ensure that you've got everything marked. And then you can either do this now from the picture or from the congruent statement. You don't always have a picture, so I like using a congruent statement. So who's in the same spot as W? That's pink. That is going to be G. So G. Angle W is congruent to angle G. So y'all, when it says congruent, that means it's looking for letters. When it says is equal, that's when it's looking for the actual measure. So what segment is going to be the same as GH? That's pink and then blue. The other triangle, that is going to be WV in that order. Okay. UV is going to be yellow and then blue. So what's yellow and then blue? I and then H. So all of these are congruent symbols, which is why I know that I'm filling in letters. Okay, triangle HIG, y'all, all they've done is they've renamed it. So we already have our congruent statement, but they've said, what if I wanted to switch this around to HIG? That's second, third, and then first. What is second, third, and then first going to be? Blue, yellow, pink. That is going to be VUW. Triangle VUW. You could rearrange that congruent statement however you want to. So since they did HIG, we would do VUW. Now notice we just changed from an congruent symbol now to an equal symbol, which means we're looking for a numerical value here. If V to U, blue, yellow, equals 10, that's segment. So if this is 10, then what do we know about HI? Blue to yellow, that is also going to be equal to 10. So notice how I'm filling a numerical value there. Now it says if angle U is equal to 85, so I'm going to go fill that in. Angle U is 85. So if this is 85 degrees, then I is 85 degrees as well. And then G is equal to 40, so I'm going to put that on both spots. So G is pink, so that's 40, which means that W is 40. Then what is the measure of angle V? So this is the one that we're looking for. We're looking for angle V. Well, how do we find angle V? We're going to do 180 minus 40 minus 85. Okay? And so that's how you can solve that. We know that we're looking for a numerical value there, so we do 180 minus 40 gives me 140 minus 85 more. How many degrees do I have left? 55 degrees. And so 55 would be for both of the blue ones. Let's say you didn't have a picture. How could you work this problem if you didn't have a picture? We would do this. So it says if U is 85. So I go ahead and fill this in up here in the statement. If that's 85, then that's 85. And then it says if G is 40. So if this is 40, then this is 40. How do you figure out what's left for the two blues? You'd go 180 minus 40 minus 85. So it wouldn't matter if they ask you for angle H or for angle V. You'd be able to do it from the congruent statement without a picture as well. Okay. All right, number 11, we have another congruent statement. And notice that we go from this congruent statement, which is going to be super important with this picture. And we want to find out what each of these is equal to, which whenever you have that equal symbol, that means that we're looking for numerical values. And so let's go ahead and color code. Y'all know I like to color code. W is in the same spot as N, so W and N. are congruent. So I'm going to go ahead and mark that. So since this is 82, I'm going to fill in 82 degrees over here as well. Then we know that S and B, those angles are going to be congruent. So here's S, here's B. So I get to copy the 67 from here, also to right here, 67 degrees. Does not look like a great 7. There we go. And then we know that these last two, T and F, are going to be congruent. So T and F. I don't have an angle for either of those, so I'm just going to mark them as congruent. 1, 2, 3. All right. And then we also know the side length. So WS is going to be the same length as NB because those are congruent. So I get to copy the 9 centimeters over there. And then S to T, yellow to blue, 17 centimeters, yellow to blue, also going to be 17 centimeters. I get to copy that across. And then W to T, 1, 2, 3, is going to be the same as N to F, pink to blue. And so that is 14 centimeters over here, so I get to copy the 14 centimeters over here. I like going ahead and doing that from the beginning because then it doesn't matter what they ask me for. I immediately know what is going to match. And so what is B to N? That is going to be 9 centimeters. What is T to W? That is going to be 14 centimeters. What is B to F? That is 17 centimeters. And now they want the angles. What is angle W? Well, angle W is also going to be 82 degrees. What is angle B? Angle B is 67 degrees. We have to do a little bit more math for angle F. How do I find angle F? Angle F, I'm going to do 180 minus the 67, rip that angle off, minus the 82. And so we're going to do 180 minus 67 minus 82. That gives me 31 degrees. So each of those would be equal to 31 degrees. That does look like an acute angle, so now that I'm doing some good math there. So if that one's 31 degrees, angle T would also be 31 degrees. All right, I'm going to go ahead and finish this part. Find the measure of the indicated value. So what do I have? The first thing I notice is that this is a triangle. And in this triangle, I have 2 of the 3 angles. So I know those should add up to 180. So if my sum is 180, what can I do quickly? I know that 180 minus the 63, so I rip off that one, minus the 92 should give me what I have left for angle 1. Okay, so I'm going to do 180 minus 63 minus 92. What do I get? I get 25 degrees. 25 degrees. And so a lot of y'all are used to going 92 plus 63 and then subtracting that from 180. The quicker way to do this if you're working on your speed, especially for the ACT, is just to rip off the angles that you have. All right, number 13, the first thing I notice is that I've got a right triangle, and I've got the right angle here, so I'm going to go ahead and fill in a 90, so I just don't forget that that does have a value there as well. And then another interior angle is 39. What I'm solving for is this exterior angle. So I want y'all to remember that we learned and we noticed this pattern that we know that the 2 interior angles are going to add up to its remote exterior angle. So meaning 90 plus 39 is going to be equal to that angle on the outside. Those 2 remote interiors add up to the exterior angle. And so if you know that pattern, that's fabulous. That makes it quick. 90 plus 39 is 129. So I know that that's 129 degrees. So x equals 129. What if you didn't remember that pattern? What could you do instead? Well, I could solve for this heart angle first and say heart is going to be equal to 180 minus 90 minus 39. What do we get when we do that? 180 minus 90 minus 39 is going to give me, I believe, 51. So if the heart angle is 51 degrees, how would that help me? If I didn't remember this remote exterior angles theorem, then I know that these are a linear pair, so then 180 minus 51 would give me that 129. Okay? So either way, if you know the shortcut, that's fabulous. If not, you can find that interior angle and then make that a linear pair. Use the fact that it's a linear pair to solve. All right, I've got a lot of triangles going on here. I've got this pink triangle that is overlapping with this blue triangle. Okay, so I want to get started. I want to solve for x and I want to solve for y. And unfortunately, for x, I don't have this angle that I need in order to immediately solve for it. So I can't start there. And for y, I could start with y because if I know that 50 and 74 add up to that remote exterior, I could also find the angle that's on the inside. Multiple ways and multiple paths that you can get started with. I do also see this 85 here. And so if this 85 goes here, it's also going to go here because those are vertical angles. And we know that vertical angles are congruent. And then we can do 180 minus 85 minus 50. 180 minus 85 minus 50 is going to give me 45 degrees. That helps me out because now if I want to use the triangle angle sum theorem, I could do 68 and 45, and x should make 180. So x is going to be equal to 180 minus 68 minus 45. And what do we get? 180 minus 68 minus 45. That is going to give me 67 degrees. 67 degrees for x. Okay? All right, again, you can do this multiple ways. If you know that rule about adding things up to the remote interior angles, adding up to the exterior, you can go ahead and just say, hey, y is going to be equal to 50 plus 74. So whenever you do 50 plus 74, you're going to get 124. That does look like an obtuse angle. But let's say that you didn't remember that. Let's say that you got stuck. What you could do is, again, put a little heart here. How do I find the heart angle? The heart angle, so this was 45. The heart angle is going to be equal to 180 minus 50 minus 74. When I do that, 180 minus 50 minus 74 is going to give me 56 degrees. And so if the heart is equal to 56 degrees, whenever you have this linear pairs add up to 180. I could do 180 minus 56. Oh, there's a horrible 6. Minus 56, and that's going to give me 124. So multiple ways to solve this problem, and we wind up in the same spot no matter what. All right, it's really going to bother me that that is blue. Let's make that black so it can match the rest. All right, so there's the front, and I will do a new video for the back.